Sevens, I hope you're enjoying Ashcroft. This video is going to be based on circuits. Firstly, my name is Ridwaan. I'm one of the sixth formers at Ashcroft, and I'll be telling you about circuits. So first of all, a circuit needs to always have a power source. Without a battery, a circuit won't function. So this particular element here is what you call a battery. And without this, the circuit would not power, because no electrons will be able to pass through the circuit itself. Electrons are charged, and charge won't be able to pass through the circuit. So the wires have to be connected to both the positive ends and the negative ends of the battery. So we can see on the battery there's a positive end and there's a negative end as well. And this is where the wires have to be connected in order for the actual circuit to work. A battery is also known as a cell. Okay, so that's a little top tip there. A circuit can also contain other electrical components such as bulbs, buzzers, or motors. This allows electricity to pass through. So bulbs, obviously a bulb will light up if it can detect the current. A buzzer will make a sound if it can detect the current, and a motor will spin if it can detect the current. And this is all to do with electricity and allowing electricity to pass through and all the current to pass through. Electricity will only travel around a circuit that is complete. As you can see here, this is not a complete circuit. This means that because it's not a complete circuit, it's really obvious that it's not complete because of this little gap here. This gap shows that it's not a complete circuit, since this wire here is not attached to the positive end of the battery. Therefore, this circuit is an incomplete circuit. For a complete circuit to happen, this is a complete circuit. This is when all the wires are connected up, as you can see clearly on this diagram, in series, and we can clearly see that the bulb is lightening. Because the bulb is lighting up, this means that the whole circuit works. Clearly, it shows that it works because all the wires are connected up from each component back to the battery, from this end of the battery, all the way here, back to the positive end of the battery. Remember that the charge flows from the negative end, and the charge flows round of it to the positive, whilst the current, it flows the opposite direction. You don't have to know that for now, but you just have to know that it lights up when it's in series. This kind of circular arrangement of all the components and wires is what you call a series circuit. Very simple. So great, we've done with that now. Now we're moving on to symbols. Now these are the symbols which you have to know about in year 7. So let's go through them. So first of all, the symbol you should know about is batteries. A battery is just simply shown if you draw one line longer than the other. So as you can clearly see here, this component is what you call a battery or a cell. This long line here is what we call a wire. So if you have a circle with a cross inside it, that is what you call a bulb. A buzzer is like a D, but the D is rotated and it has two lines here. That's a buzzer. Quite a tricky one to get your hand around, but it could be easy if you vision it. Motor, however, it has a circle and an M. M, obviously, it represents the word motor. Quite easy and quite straightforward. Here we have a switch. So obviously we can see that the switch here is off because the wire here, which is represented by this component here, is not connected. So therefore it is off. But here the wire is connected. So that means it is on. This is a closed circuit whilst this is an open circuit. So now we're talking about switches now. So when a switch is off, there's a gap in the circuit. Electricity cannot travel around the circuit. So here we can see that there is a gap in the circuit. Because there's a gap in the circuit, that means when electrons pass through the negative end of the battery, through the bulb, this is clearly an example where the circuit won't work because the switch is off. This means that the switch is open. Because it's open, that means when the current moves from the positive end of the battery around here, down here, it will go up and it won't really go towards the bulb. There's no way the current will be able to access the bulb. It will never be able to reach the bulb because the switch is open. Because the switch is open, that means the current will just be going and it won't really do anything. It will just go and it will just be wasted. Okay? But if the switch was closed, however, it will be much better because therefore we can see a complete circuit. Okay, so when the switch is closed, we can clearly see that the current can move all around the circuit freely, go to the bulb and enter back into the battery through the negative end of the battery. This end of the battery here is negative, and this is where the direction of electrons travel. The direction of electrons travel in this direction here, so it travels on the right hand side. Okay, so this electrons is referred to as charge, where here this is the positive terminal of the battery, and this is where current travels there. So current travels in the left side. So current and charge always travel in opposite directions. So that is why the current will never be able to reach the lamp if the switch was open. So if the switch is open, no current will be able to reach the bulb, and therefore the switch won't work. But here, the bulb will light up because the switch is closed and everything's complete. Okay, so this part now I'm going to talk about is changing circuits. So it's about what components, if you add more components or if you remove components, what will happen to the circuit. So if we add more batteries, so as we can see, this is a battery. Okay, this is one cell. So if in here we can see there's two cells or a battery. So if you add more batteries to the circuit, this will increase the electrical energy which travels in the circuit. Because there's more batteries in the circuit, it will increase the amount of energy which travels in the circuit, and that means the bulb will obviously be more brighter. Because the more battery, the more energy, and the brighter the bulb will be. If we add more bulbs, it will make the actual bulbs between them, it will be dimmer. So the bulbs will be shared, the current will be shared between them. And because the current is shared between them, the bulbs will be dimmer, because that's what happens when you add more bulbs. Adding more bulbs means that the current is shared between them. That means that the bulbs will be dimmer. So let's think about this now. Now this may seem very confusing, but trust me, it's really straightforward. So if you add a motor, again, the same thing will happen, is the electrical energy which flows around the circuit, the motor will just rotate. Okay, think about a car motor, right? In a car motor, what happens to the motor in the car? It rotates. Every motor you come across in physics, and every motor you come across in real life is the same thing. A motor rotates. In a circuit, if you add a battery, more energy will rotate around the circuit, and the motor will rotate even faster if you add more batteries. The more battery, the more electrical energy, the motor will move faster. Less batteries, less energy, motor will rotate slower. So that is what you have to understand about motors, and what their job is just to rotate. Okay? And when they have enough energy, they will rotate. So when you do your exams, the examiners might be very cheeky. Now look at the first example here. Well, when I look at this first, I can say, wow, this is a complete circuit. You know, everything's connected up. But when you come to this point here, you can clearly see this is not connected straight. Now, this might be very tricky to recognize in the exam. But no, guys, this is wrong. Okay, this is a wrong, incomplete circuit. Because this wire here is not connected fully with the bulb, that means when the charge flows, the charge won't reach the bulb, and therefore the bulb won't light up. This is an incomplete circuit because the wire is not there to complete it. Or we can also add a switch there to close the switch and complete it. But because the wire is not there, this is an incomplete circuit. Now, the second diagram is a bit more straightforward. We can clearly see that there's no battery. Because there's no battery, there will be no electrical energy. And because there's no electrical energy, the bulb won't light up. And the third example, and the last example of my presentation. This is a complete circuit, where all the wires are connected across each component successfully, and the battery is there as well. This clearly shows and indicates that the bulb will light up successfully. Okay, so that's three things which you have to make sure you understand in the exam. An incomplete circuit, a circuit with no battery, and a complete circuit, where everything is just beautiful.